at IAA 2016. There is a good display of technology and new products here. Please take us through your display at IAA 2016.
Okay, maybe we start with this display here. We have, on this display we have a Euro 6 concept box, which is containing the most important catalytic elements you need for Euro 6, which is the POC, DPF and SCR, dosing technologies, injector, mixing units. So that is what is standard today. And now the question comes up, what's important for Euro 6 Plus, or what's coming after Euro 6? You see there are two key things. One thing is CO2 regulation and total cost of ownership. This is driving the need for waste heat recovery technology, and what you can see is the key element of a waste heat recovery system, a Rankine system, is the heat exchanger, which is recovering the energy from the exhaust system and converts it into mechanical or electrical energy. That is a key element, which is the evaporator Rankine system. The other thing we talk about, if you talk about future of Euro 6, is NOx. And we are going to have a much more reduced NOx emission limit, because if you compare it with North America, they are already at 0.02 grams per brake horsepower an hour, which is about a factor 15 lower than what we have today in the discussion in Euro 6. So I'm very sure that there's going to be a further reduction of NOx. And what this means is you need to have more efficient SCR technology. More efficient means better sensors, higher dosing accuracy, but also thermal management tools, either passive thermal management in terms of fabricated manifolds with air gap insulation, or fabricated insulated downpipes to keep all the heat in the system. And if this is not sufficient, to add extra heat to the system, and that's what we call active thermal management. And for this we use thermal units like this is a placeholder. It's our prototype of a True Clean mini burner. It's already a thermal response unit to increase temperature. It was meant to be for DPF regeneration, but today we talk about SCR improvement, and that means supporting or bringing energy and heat to the system at a lower temperature level, 140 to 160 degrees C, and then heat it more up. And that's why we use this kind of units, but at a much lower scale, without an air pump. The intention is to supply something like around 5 to 10 kilowatt of heat to the exhaust system, and that will make the SCR technology extremely efficient. Other very key important components that you need for efficient systems is the mixing section. This is again just a snapshot of one example we had in this concept study. All the key elements you can see over there on the back wall. Can we go? Okay, what you see is here is our mixing family. One of the key elements of our mixing family is this tube. We see that is a scale. We call it a swirl pipe mixer. This pipe mixer is containing the fine spray that you inject on this side here in a swirl, and then after this zone it brings it control to the wall where it has a chance to evaporate. So you can see this is a zone where the spray is protected, and this is a zone where the spray is getting to the wall and being efficiently evaporated, because that is the first step in the way to process the AdBlue that you inject into ammonia.
Sure.
So this mixer here, this key functional element now goes into many applications, either behind the outlet cone of a substrate, or it could also go in a separate box, like you can see here, and where this piece is installed here, and this perforated tube just make the flow for getting where it comes from, so it can come from here, from there, or from there. Does not matter, it's always the same function, and you can turn the tube in all directions. This device is giving you maximum flexibility for installation of all kind of machines. We'll take this device and now go back into this machine, this Euro 6 box, and you can integrate it there. This is a key functional element. Mixers we were using so far were this kind of impact mixers, where spray was hitting walls, but this is leading to the formation of deposits at pretty low dosing rates already. So this is Euro 6 or Euro 5 technology, and this is going to be the technology for Euro 6 and later. And maybe last but not least, It makes that one thing, but a good dosing system is another key element. If you look here, you see the Tenneco X-Nox dosing system, consisting out of a box with a controller, a pump, and a filter inside. And then this box or the pump inside is pumping the fluid to our injector, where a piece of that is injected into the exhaust system. And you see the spray is extremely fine, very small droplets. And a part is injected, and the rest is going back through the center of the injector back into the tank. And this is cooling the injector extremely efficiently from the inner side. The injector is AdBlue cooled instead of being water cooled, as many others have. That's very favorable. And you have seen the extremely fine spray that we have. This is this mandatory technology you need for fulfilling the high SCR efficiency requirements for Euro 6 and later.
So in a nutshell, you're trying to convey that SCR in the longer run is the efficient technology?
Yeah, SCR is as such perfectly efficient, but with good spray, good mixers and thermal support, it's going to be even more efficient. We just managed to build up an engine at the laboratory in US, which is already fulfilling 0.01 grams per brake horsepower an hour, which is again factor 2 lower than what is being discussed so far for CARB 2020. So that is very efficient, and the efficiency of this system is going up to 99% under good thermal conditions, or up to 98-99% also in the full cycle.
Correct. There's also emphasis on lightweighting the vehicle overall components. Can you shed some light on how it is done in this? Is it lightweighted?
Well, lightweighting is another way to save fuel, to reduce CO2 emission. Of course, we are also contributing to lightweighting in terms that we select materials, which are light, makes the wall thinner. And you have seen the manifold I showed you on the other display. This manifold is replacing a cast iron manifold. The wall thickness of this manifold is just 1.5 millimeter compared to typically 4.5 millimeters for cast iron manifold. So there's a big factor of weight saving if you apply our technologies.
Super. Thank you, Mr. Terex, for joining us on Motor India Transport. It was a pleasure talking to you.